right, this is your bell ringer today. Some things we have to know how to do in our lesson today.
Yeah.
Some review. Ringer. Answers should be those. 50 minus 2x, 190 minus 3x. On number 1 and 2, you can't solve. They weren't equations. There's no equal sign up there. So you're just really simplifying. You're putting together terms. You're distributing the subtract to, or let's see, you're multiplying each part by -2 or multiplying by -1 to do the subtraction on there. And then 3 and 4, x equals 4, x equals 16. Like to see a problem demonstrated. Problem 4. Okay, problem 4, we have a lot of stuff on the left-hand side. Let's try and make this smaller, okay? And it's just adding. So 4x plus 5x is 9x. Subtract 8 plus adding 4, so like -8 plus 14. I think I said 4, but 14. That should be positive 6 equals 150. Now I'm ready to do some opposite work to cancel things out. So subtract 6, 9x equals 144. 144 divided by 9 should be 16. Right. Others to see? Okay, are we comfortable with number 1 or 2? You need to see one of those. Tell me got them right. 1 and 2? You got them right? Okay. Okay, you need to subtract each part. So where's that 190 come from? Well, if we're subtracting 3x and then we're subtract 10, that's like adding 10. So 180 plus 10 is where that came from. All right, and how are we doing on the solving algebra worksheet? How many have worked on it? Did everybody started on it yet? No? Some didn't start yet? Okay, hands down. As soon as you get that done, turn it in. I did get some from second period already turned in, so if you're finished with it, you can get it turned in, and I'll try and get it checked. Right. And if you want to come in like 5th period and check your answers to see how you're doing, I'll make the key available during 5th period if you want to come in and take a look at it. Make sure you're doing them right. Okay. All right, let's move on. Got just 3 questions up here on homework. So the page that we were on was 24. I guess if you don't have questions on these, you can do a few algebra solving problems while you're waiting. Number 9 and 10. Okay, those deal with the same directions, and there's no picture that goes with problem 9 or 10. So what I'm going to do is read through the directions and build a picture. It says ray BD bisects angle ABC. I have no idea how big angle ABC is. I'm just going to draw a random angle, call it ABC. And then ray BD bisects the angle. Okay, what's it mean to bisect the angle? Cuts it in half, right in the middle. Okay, so BD, maybe about there. I want this part and this part to be equal. I want it to bisect. Then number 9 says angle ABD is 6x plus 4. And angle DBC is 8x minus 4. Okay, how would I find what x is, and then I have to substitute in and find a certain angle. Isabel, ideas on that one? Okay, she said put 6x plus 4 equal to 8x minus 4 because they're congruent, they have to be equal measure, they bisect is the basis of that. Okay, on number 9, do you need me to do the solving part? We can see if there's any yeses or no. Okay, I don't see any yeses. So we'll go on to number 10. Okay, number 10 uses the same picture, so I'm building it again. Maybe this would be, let's see what we know, and it isn't bisected. And this one, angle ABD is 5y minus 3. And DBC, so again, I'm giving you the two small ones, 3y plus 15. I thought maybe that one would be set up different, but it looks like it's the same kind of problem. So again, 5y minus 3 has to equal 3y plus 15. I think maybe what the difference was is what angle you're supposed to find when you're done. The first one, you're supposed to find angle ABD, but this one, you're supposed to find ABC. So once you find that, find the angle ABC, which is the whole thing. Do I need to do some more on that one? Okay, number 30. 30 had a little bit more complex picture. It had a line and there were a bunch of rays off of it. So I think it was A, B, C, D, E. I think that was O. There were markings on it. There was a tick mark here and here, which means okay, those are the same. They're congruent. Okay, and it tells me angle AOB is 4x minus 2. Angle BOC is 5x plus 10. 5x plus 10. So then if they're the same, this one's also 5x plus 10. Angle COD is 3x minus 8. 3x minus 8. And we'll point D so it's not interfering there. Okay, we need to figure out an angle. Actually, we need to just figure out what x is. If I put 5x plus 10 equal to 5x plus 10, that really doesn't get me anywhere. It just cancels out. Ideas on this one?
Angle of them equal to 180 degrees.
Okay, which one's equal to 180?
All of them together.
Okay, all of them together. What's he basing that on? Where are you getting the 180?
To the straight line, the
Okay.
straight angle.
The straight angle. Yeah, from this ray all the way around to that ray. All of those have to total 180. So add them all together. Maybe I'll help you simplify it just a little bit. But together, they all have to add up to 180 degrees. So 5, 8, 5 more is 13, and 4 more is 17. So 17x, 10 minus 8 is plus 2. It's 10 more, so I'm positive 12 right now. Minus 2, so plus 10. And I think you can go from there if I were to finish. Alright, so the straight angle was the key to that one. Alright, those were the 3 questions. Alright, so hand that to the person on the left. A few people are finishing that problem. Pass it to the left, get a different color pen or pencil to check with.
Do you want me to give this to?
It would be the next one, so.
Okay.
As far as the quiz today, I usually do the quiz towards the end of class. We'll go through the lesson and then have you work on the quiz. That way, when you are done with the quiz, you can start on your homework. You don't have to wait for everybody else to get done. Some like it that way, some don't, but that's the way I think it works pretty good. So you know, I don't have to set a time limit exactly. Okay, page 24, number 1. Has to be in this order. Angle A, angle R, angle O. Number 2, vertex is point C, and that would be ray CB and ray CD for the sides. Number 3, naming the angles. Angle 1 could be named that way, or angle AOB or BOA. Could have angle 2, or you could also call it angle BOC or angle COB. And And the big angle was either angle AOC or angle COA.
What if they just had angle AOB, angle BSC?
I think that was one of each of them, so yes, they're good. All right, so I gave multiple ways to do angle 1 and angle 2 and a big angle.
On two of his angles, he's got the equal sign.
Forgot the angle sign, I go half them. Does it sound like there was one of them that was marked, right? Okay, ready for number 4. Number 4 is 15 degrees and it's acute. Number 5, 105 degrees and it's obtuse. They forgot the classifying, that's half. Number 6, 110 degrees, obtuse. Number 7, 70 degrees. Number 8, 26.1 degrees. Number 9, 28 degrees. Number 10, 84 degrees. Number 19, acute, 20 right, 21 acute, 22 obtuse. Okay, the next ones, they had to draw a certain angle. You probably did a protractor. They had to draw it a certain number of degrees. Question back there?
For 19 to 22, what if they just wrote the degrees, not the up to the?
So for which one's 19?
For 22. They wrote the degrees.
They just estimated, it says and classify, go half on each one. Okay, the angles that they should have made. Number 23 was 33 degrees. I'll list them up on the board here. 24 was 142. Give them maybe 1, maybe 2 degrees for a maximum error. Okay, those 4 problems. And I guess while you're at it, you might check number 40. 40 had to be 70 degrees.
Yeah, but this is.
Okay.
Thanks for telling me.
Chase was gonna take the protractors, but
I have my own protractor.
Yeah, I have my own, but I hope it's like trying to make my own phone.
I can go and cancel your protractor.
it probably did.
Really? That's awesome. It does? Oh, that was
Just
Maybe?
Hey, for number 7, they just have 35. It's
it should be able to.
No, they just like have.
I got a calculator and an office chair.
Yeah, just like 35.
And books, that's right.
Yes.
On
Practice. The usual. Just what I wanted to do. No.
That's like how it works on.
Okay, let's go on.
Well, like this kind of stuff.
What is that?
Like,
Read that right.
Okay, on problem 27. 27 should be 67.5 degrees and 22.5 degrees for the two that you're supposed to find. Number 30, x was 10. Number 40, they start with a 70-degree angle, but then they need to construct. So you gotta see, did they really construct? So on their 70-degree angle, you should see an arc that goes through there, and then you should see an X where they drew their angle bisector. If the arcs are not there, they didn't do the construction, so you're gonna miss the problem.
What if we did like the first one, but not the next?
That still isn't a complete construction. Gotta have the X there so that you know where to draw that ray at, okay? And I think the problem, they were supposed to figure out that this would be 35 degrees and this 35 degrees, but to support the construction, I need to see the arcs. If the arcs aren't there, then they probably just drew it with a protractor. Right, number 41 is B, 42 is H, 43 is C, and 58 is 8. You're supposed to find JL's length. JL's. That should be the end of the required part.
Wait, what were the two, the three answers?
Okay, yeah, D, H, and C. The one, the last one was
Okay, get that board and return to its owner, please.
What deal is that? I put the angle sign lines on three, but Chris, no one is off the.
Yeah.
You're getting that sign.
There it goes. Yeah.
Oh, what? Oh, yeah, that's one.
Just remember,
And I took.
Because it didn't have the measurements.
You're supposed to put, you're supposed to put 35 and 35. Whatever, I don't care. Just do something. Just say it's fine.
Okay, any follow-up questions on that assignment? You do have a quiz that covers that, in about a half hour. Anything to talk about? Okay, if not, hand those forward, and we'll get in the basket, get out your notes.
Why do you?
What did I get?
Okay, the middle one wasn't. They currently put 31.
Yeah, it was.
Yeah, I know. But Chris's angle, see how this one, like, and I measured it, it wasn't.
I hope you. This is blasphemy. I think they will, leave the angle back.
All right, let's go to lesson, was it 4, I think? Okay, the lesson for today is actually kind of two parts, two real short lessons. I'm going to talk you through the 11, or the 1-4 lesson, and then part of your assignment will be lesson 1-7. If you want to look at what 1-7 is, it's about translations, rotations, and reflections, different kinds of transformations. And I believe you should have heard those words before, and if not, the section in the book, I want you to read through, complete your notes, and there will be like 15 homework problems that I want you to do from that section. We'll talk about some questions you have on it tomorrow, if you have some. But that's a section that I think you can read and understand with maybe just a little bit of guidance. So that will be part of what your assignment is today. So I'll take you through lesson 1-4, which really has 5 vocabulary terms on it. So we need to explain or clarify what these different pairs are. Okay? Some of the angle pairs that we're going to be looking at today, or the terminology, is based upon how the diagram is set up. And where are the angles and how are they positioned in the picture? Other relationships or other terms are just based on what the degree measure is. So whether the picture is there or not on those, it doesn't matter. The first two are based upon how the picture is put together. adjacent angles and linear pair are the first two that we'll talk about. Okay, so as far as your notes, you'll want to add some pictures, maybe some explanations to that. Adjacent angles are two angles in the same plane, so they're flat on the same surface. They have a common vertex and a common side, but no common interior points. In other words, they're going to be hooked together at the corner. They'll be hooked together sharing a ray, okay, side by side, not overlapping. If they're overlapping, that's when they would be having some common interior points. And we want them to be side by side. That's called adjacent angles. So in that picture off to the right, angle 1 and 2 are adjacent angles. Okay? They don't have to be the same size. Those kind of look like they're close, but you can have one real skinny and one real wide. But just side by side, basically. Then the linear pair term is actually related to that. Linear pairs of angles are a pair of adjacent angles, so they do have to be two angles side by side. But they also have to have their non-common sides making opposite rays. So if you look at the picture with angle 3 and 4, angle 3 and 4 are hooked together. This ray is the one that they share. So the non-common sides would be the ray to the left and the ray to the right. Those together, they look like they make a straight line. That's what our picture of opposite rays looked like. Two rays that start at the same point and go in completely opposite directions. That idea of them together making a straight angle is where they get their name, linear pair of angles that together would make a straight angle. We're going to clarify a few. Let's practice some naming on it. Okay, here's a picture. We'll put that, we'll add another one, add another one. In this picture, I have three angles. Right, are angle 1 and 2 adjacent? They share the same vertex, they do share a side. This is the ray that they share. Okay? So 1 and 2 are adjacent. How about 1 and 3? No. Okay, the rays that make angle 1 would be these two, and the rays that make angle 3 would be these two. So they are not the same ray. They are hooked together at the same vertex, but not sharing a side. Okay, let me add to the picture. I'm going this direction. There's angle 4. Is angle 4 adjacent to angle 2? No. Is angle 4 adjacent to angle 3? Yes, it is. Is angle 1 adjacent to angle 3? Okay, that sounds like we're getting that. How about linear pairs? Okay, 1 and 2, are they a linear pair? Are they adjacent? You told me yes. And then do their opposite sides, the non-shared ones, I guess I should say, non-shared sides make a straight angle? No, that's what the non-shared sides would look like. So 1 and 2 are not a linear pair. How about 1 and 4? Here's some yes and here's some no. Okay, angles 1 and 4, are they adjacent? Well, if they're not adjacent, they can't be a linear pair. So linear pair, no. You might be saying, well, they have opposite rays. Yeah, I would agree, that ray and that ray are opposite rays, but angle 1 and angle 4 are not hooked together. They've got that gap between them. So it's not just those two angles that makes the complete straight angle, but you have to skip over a few. So because of that gap in between there, it's not a linear pair. We're not going to be able to come up with a linear pair easily in that diagram. So let me change the picture a little bit. Let's go just two crossing ones. 1, 2, 3, 4. Okay, are angles 1 and 2 adjacent? Yes. Are angles 1 and 2 a linear pair? Okay, yes, that's an example. Because angle 1 and 2 are the only two angles that get you around to that total of a straight angle. Angles 2 and 4, adjacent? No. Linear pair? They're not adjacent, they can't be a linear pair at all. No. They are made up of the same two lines, but they're not either adjacent or a linear pair. Okay, how about angles 3 and 4? Yes. Okay, they are adjacent and they do form a linear pair also, correct. Okay, so there's a lot of linear pairs and adjacents in that one. Okay, grab your marker board. I'm going to use a few pictures that are already created here. Now your choices are only adjacent, adjacent and form a linear pair, not adjacent. So angle AEB and angle BEC. Angle AEB would be this one. Angle BEC would be this one. So are those two angles adjacent? Are they adjacent and making a linear pair, or are they not adjacent? Okay, show me. Not a linear pair. These are only adjacent. They are hooked together, but when you go to those non-shared sides, it doesn't make a complete straight line. It wouldn't be 180 degrees total. All right, same picture. How about angles AEB and BED? AEB would be that angle. And then BED would be this angle. So you're really ignoring ray EC. You're ignoring that ray. Okay, show me. These should be adjacent and a linear pair. Now they are adjacent because the two angles each have ray EB as a side of it. That's the side of both of the angles that was named, that were named. Okay.
Okay, that's totally off.
Question on that? Okay, let's try another one. Yeah, because you had like 2 answers, didn't you?
Yeah, I was off.
All right, how about angle DEC and AEB? So either only adjacent, adjacent and linear pair, or not adjacent. Show me. These are not adjacent. Okay, they're not adjacent because the rays that make angle BED would be these two green ones. The blue ones over here are the two that make angle DEC. None of those are the same ray. If you're thinking that ray ED and EA are the same ray, no, those aren't the same ray. They go in completely opposite directions. They're different rays. All right, let's keep going a little bit. Get rid of my ink. There we go. Okay, different picture. How about angles 5 and 6? Same choices. Show me. That one was adjacent and linear pair. We did better on that one. How about on the same picture, angle 7 and angle SPU? Read your definitions if you need to. Some of these markers stick an extra in your bag. Okay, kind of questioning on that one, huh? Show me what you think. What if you are saying not adjacent, and that is correct? Now, those of you that said adjacent, do they share a vertex? Yeah. Do they share a ray? What ray was the shared one? I don't think the ray PT was the shared one, was it? Angle 7 was these two rays. Angle SPU was these two rays. So the shared one was ray PS, which is not between the two angles, it's like to one side or the other. So why are these not adjacent? They share a vertex and a common side. Yes, they're overlapping. The rest of the definition said, but no common interior points. So if you pick a point in here, this point is in angle 7 and it's in angle SPU. So that's an overlapping shared point. So they need to be side by side rather than one inside the other. Okay? All right, that one was a good one. How about 7 and 8? And show me this one. What'd you think? All right, why are these not a linear pair? Because they're not adjacent. Angle 7 is made up of those two rays. Angle 8 is made up of these two. None of those rays are the same. Okay, let's go to the next terms. So in your notes, you'll now see complementary and supplementary. We'll use the marker board again. Okay, close. Now complementary and supplementary angles, doesn't matter what the picture looks like. We just need to know what the measures are. Because complementary angles are two angles whose measures have a sum of 90 degrees. So two angles that add up to 90 degrees. So if one angle was a 20-degree angle, how big would the other one be? 20 and 70. Those would be complementary. A 20-degree angle and a 70-degree angle because they add up to 90 degrees. And it's two angles, it's not 3 or 4 or 1. A right angle isn't a complementary angle. To be complements, you need to have two angles. That's a pair. So in the picture up there, which ones are the complementary angles? Angles A and B, because 53 degrees plus 37 degrees adds up to 90. Supplementary angles, again, are two angles. Their measures add up to 180 degrees. And I don't have to have a picture, but if you have a 20-degree angle, how big would the angle be to be supplementary? 20 degrees and,
160.
yeah, 20 degrees and 160 would be supplements. How about the ones that are up there? Which two add up to 180? A and C, right, 53 degrees and 125. So you can add them and see if they add up to 90 or add up to 180. Another type of question is, if I'm telling you one of them, you can subtract to find the other. And that's what I was doing with the 20 degrees. With a 20-degree angle, you get 90 minus 20 to find the other one. If they're complements. If they're supplements, 180 minus 20. So we'll do some subtracting. Let's practice here. We're gonna pair up on this one. Let's switch our pairing. Okay, let's go, these two rows pair up. Okay, maybe the odd row. These two pair up. And here, how about first three, you can talk and then back to. So this week, let's use that pairing. All right, so pair with your partner and figure out the complement of angle F and then the supplement of angle G. And if you're without a partner, just join a group.
Okay, so that's 90.
Oh wait, yeah, we're doing something. So you said I was
I can't see.
And then a supplement of G. Well,
So it has to be 180. So 180 minus that.
plus 610.
I got that part. Wait, hold on. That doesn't work, does it?
Probably not.
No.
Wait, you know, well, I think that's actually like, right.
And then you do this.
Or do you do like?
That's what I was thinking, I don't know how.
170. I don't either.
right,
No, I don't think so. What are you
That plus X equals something. Is there any index? I cannot make this any. Me no English.
I don't really know what to do.
Chris, how do you use this?
You know what, right? Maybe you should have some bits.
Well, you're smart, so I asked you. Chris doesn't.
You don't know this? Come on. There is no other X.
It's not just that angle, it's that angle that goes out.
But the X would be the X.
I can assume that that X is the same X. You know, that.
No, it can't be the. No,
That's not
Minus 7x plus 10 equals whatever the other thing is.
Minus 7x plus 10.
Oh, okay,
Like, we're filling shit.
Yeah, look at that. Not very much.
The second one. Okay, let's talk a little bit up here. Okay, first one, I think you probably all subtracted 90 minus what I gave you and you got 31. But then you got stuck on the second one. Well, second one, they should add up to 180. So instead of subtracting from 90, shouldn't you subtract from 180? So you want to take 180 minus 7x plus 10, like the bell ringer. Subtract each part. So it should be 170 minus 7x. That's the angle. I'm going to try and convince you that that's actually the correct one. Okay, now wouldn't the two angles, angle G and I'll just call it supplement, shouldn't those add up to 180 degrees? That's the idea. So what I'm going to do is check your answer. Okay, angle G was 7x plus 10, and the measure of the supplement should be 170 minus 7x. Let's see if those do add up to be 180 degrees. 7x minus 7x cancels out, right? 10 plus 170, that's 180 degrees when you add those two. So this is the correct supplement for the angle that I gave you. Now, this isn't how you find it, but this is how you check it. You found it just by subtracting.
So that's your answer?
That's your answer, that the angle would be 170 minus 7x degrees. Yes.
Where'd you get 170 minus 7x?
Okay, can you see at the bottom of the screen here? 180 minus the angle that I gave you. You want to subtract 7x and subtract 10, distributing it. 180 minus 10 is 170. Minus 7x. Okay, let's try another set. It's kind of like that. Complement and supplement of what's up there. You can still work with your partner if you get each other to understand it.
All right, Kate. Let's do A.
Okay, complementary, okay, so
And let's
we have
exclude Melissa.
90 minus
Well, but that's
Subtract the whole thing. The sign's right. That's the correct idea.
You ended up being plus 12, and then be 102.
Would be the answer then.
check that, then you win. Negative 7x minus 12 plus 102 minus 7x
Negative, it's basically negative
90.
7.
I'm doing this.
Then you
These cancel out.
plus.
Negative 12 plus 102. Would be 90.
Okay, guys, I got this.
Just the first one.
7x.
Oh, and that's how you even check on it.
Oh, that's all right. I don't know how to subtract.
You know,
What,
you
78 is
divide it with
problem?
78.
Number A.
A.
Number A.
Letter A. Chris.
What did I do?
Okay, let's try this. Gotta watch your signs.
Oh, oops.
On the first one,
Wait, what?
102 minus 7x. Where'd I get 102? Why didn't I get 78? Well, because you want to subtract this whole thing. So subtract 7x and subtracting 12, or subtract negative 12 if you want to think of it that way. Subtract negative is adding positive. And then the second one should have been easy. 63 and a half. Okay, clarifying questions. Okay, so this type of problem is where I gave you one angle. Sometimes I gave you just a number, sometimes I gave you an expression. So to find the complement or supplement, you just subtracted to find the other one. I gave you one, you subtract to find the other. What if I don't really give you either one? Let's skip that one. At the top here, I kind of gave you what they are. This angle is 2x, this angle is 8x minus 20, but I didn't exactly tell you what either one is. On this type, to get them to be supplementary, you can add them together and set it equal to 180. So on problem 1 here, take 2x plus 8x minus 20 equals 180 degrees. Solve for x. It's an equation when you know the two angles added. So add those two angles, set it equal to 180 degrees.
Then we can put it back in.
And then substitute in to find the angles. Correct. Once you think you know what x is, substitute in to find each angle, and to check it, they're supplementary, they should add up to be 180 degrees. So x was how much? 20? So then 2 times 20, angle XYZ was 40 degrees. And 8 times 20 minus 20 was 140. All right. All right, try the second one. Okay, do your two answers add up to 90 degrees? You should have x to be 11, and the angles were 22 degrees and 68 degrees. So a couple kind of problems. If I tell you one, you can subtract to find the other. If I give you something for both of them, then you can add to make them supplements or complements. Okay, how are you going to remember complementary and supplementary? Some students have said a C has one curve, the S has two curves, it's twice as much. The P's, complementary, one P, supplementary, two P's, it's twice as much. If that helps you in any way, you can use those ideas.
I know.
And the last term is vertical angles. So back to your notes. Vertical angles is another pairing that's based on what the picture looks like. Vertical angles are two non-adjacent angles, so they're not going to be side by side. They're not going to be side by side, but they are formed by two intersecting lines. So angles 1 and 3 in the picture here, notice they're like across from each other rather than side by side. Vertical angles are like that. They're across from each other, formed by the same two lines. Okay, and angle 2 and angle 4 are vertical angles also. Vertical doesn't mean one up, one down. In this context, it's just across from each other. Be careful on diagrams that might have an extra ray in there. They throw this one in here. We'll put a 1 and a 5. Now be careful, 1 and 3 are not vertical because they're not formed by the same two lines. Okay? It would be 1 and 5 together, vertical to 3, but not just 1 or just 5. So be careful on those. So let's look at a couple pictures to name some vertical angles. Okay, so on your marker board, or if you want it in your notes, I guess, name a pair of vertical angles. Now, there aren't numbers up here, so how are you going to name the angle? You need 3 points. A side of it, its vertex, then the other side. So pair them up. Which ones are vertical angles?
How do you pair?
Like that one, comma, and then the other one. There's one answer. All right, the pairs would be angle HML, or you can reverse those letters completely. HML is the one on the left, JMK would be the angle on the right, those are vertical. Then angle HMJ is the top one, angle LMK is the bottom one. Thumbs up or down if you get it right. All right. We need to do a second picture. I think there were lots of thumbs up, so. Okay, let's go to the homework assignment and quiz then. Did you study? Well, might be the direction. Might say name array. You gotta know what array is and then name it.
I know the stuff.
Create a letter angle and then.
Yeah, give it a chance.
I know.
Okay, the page 31 is based on the lesson I did with you. Okay, what I need you to do then is also page 53, 1 through 15, with the notes for lesson 1-7 taken from the book. So in other words, you need to do the notes and then try those 15 problems. It's based on reflections, rotations, and translations, like identifying which is which. Depends if you're flipping it, turning it, or sliding it. So read through that, look at the kind of notation that is there. As a reminder about your algebra solving. Algebra solving. And today is a fifth period, you can come in and ask some questions if you need to, or check something. Okay, so once you get that written down, put your things away, keep the bag of supplies, because you do need to, on the quiz, do a problem with the protractor. So you'll need that during the quiz. So as soon as you are done with your quiz, you can bring it up to the basket, and then you can go back and get your books out and start on the assignment or the notes. That way you don't have to sit and wait for everybody else to get done. So really everything off your desk except something to write with and the packet of supplies.